we have our next talk for today, a really great talk. If you've been seeing this, this badge around everyone's neck, this is the guy that's done it. Peter Rankin introducing the new bPod. Let's welcome him to the stage.
Okay. This is a day that I've been looking forward to for 15 years, because I had this idea when I finished up at uni. Every once in a while, a revolutionary conference badge gets released. And BSides Canberra has been fortunate enough to release a few of these into the wild. In 2016, we released our first electronics badge. With the screen and buttons, it also supported Wi-Fi and a live Twitter stream. It showed what a conference badge could be. In 2018, we introduced the bus side, and it didn't just change the way that we repurposed conference badges. It changed the entire way, the entire purpose of a conference badge. In 2019, we went all out with nostalgia, trying to engage the hackers in this very room. This also was the first badge that we incorporated a QR code scheme as a means of network and interactivity. And then our most recent one, in 2022, we had our most advanced electronics badge that we've ever done. And it showed how far you can go with a conference badge, from an e-ink display, some Wi-Fi capabilities, buttons, everything. Well, today, I'm pleased to announce that I get to introduce 3 new products in this class. The first, a color screen badge with touch controls. The second, a revolutionary hardware and learning device. And for the third, a breakthrough hacking and CTF challenge. So what do we have? We have a badge, a tool, and a CTF. A badge, a tool, a CTF. A badge, a tool, a CTF. Are you getting where I'm going with this? These aren't 3 separate pieces of swag that you get at this conference. This is one device, one badge, and we're calling it the bPod. Today, BSides Canberra reinvents the badge. And here it is. This was actually the first prototype I did back in late 2021. This is the actual one that you have around your neck. So before we get into the story of this badge, let's talk about a category of things called smart badges. So when you go to conferences, they'll have some LEDs, maybe a screen, a microcontroller, some challenges. And you know, they might even have some utilities, like some Wi-Fi scanning and things like that. And the problem is that sometimes they're not so advanced, and they're not so easy to hack. And let me sort of break this down in a Business School 101 graph. So we have how easy it is for you to hack it and modify it, and how many advanced features it has on it. And so most conference badges will sort of sit around about here, where they have some LEDs and a battery, but they don't necessarily have a USB port or necessarily easy to program. But then if you look at some of the previous badges that we've done, they do have quite a few features and color screens and things like that. But again, they're not so easy for you to modify and hack. They may not have the right USB ports. They may require custom programmers or tools or software. Well, we don't want to do either of these things here. What we want to do is we want to create a leapfrog badge that goes all the way so that something that's easy for you to hack and modify, but also has some advanced features for you to use while you're here. And that's exactly where we want the bPod to land. So how are we going to get here? Well, let's break this down. the first part that we're going to need is a revolutionary user interface for you to be able to interact. Why do we need this? And this comes from years of watching you hackers use our conference badges. Let's take a look. All these badges, they arrived at our attendees, and they worked for the most part. But the issue with these badges is actually in this part. Because when we order a large number of screens or microcontrollers, we hit issues. We hit issues with supply, with the same screen having different internal hardware drivers. We have microcontrollers, which you can't use all of the pins as GPIOs. In fact, on your bPod this year, one of the LEDs doesn't actually turn on because there's an undocumented feature where you can't use pin 46 as an output. The other thing is that if we do it without a screen and buttons and just do a console, not everyone brings a laptop to a conference. And so if you have to wait to get home to make use of it, it's going to end up in a drawer or a cupboard and not see the light of day. And we don't want that. There is a single point of failure here where there's a chance that you won't be able to use your badge as it was intended. So how are we going to solve this problem? Well, we already have. It's called redundancy. Why don't we create something where we have both the onboard input-output controls, a screen and buttons, but also have the console interface. So if we can't get you a screen or the buttons don't work, you can still use and interact with the device. And so we take the concept of our previous badges and we mix it together and we come up with this. Your bPod, when it's hooked up to a computer and a serial terminal, the entire user interface, and I mean the entire user interface down to the games, is replicated in real time on the console. And this provides some very interesting use cases. You can play the games on the bPod screen using the keyboard or mouse on your laptop. Likewise, you can navigate the console window using our touch wheel. It works flawlessly like magic. So how do we get here? Well, it starts with design. And if you talk to the conference organizers, the most important part is doing it on a budget. Because believe it or not, if it's too expensive, we just can't do it because we want the conference to run. Or maybe we do limited supplies where only some attendees get one. We don't want that. We want a controlled budget so that we can get this stuff into every single person's hands at this conference. So how do we do this? We keep it simple. A 2-layer PCB with copper tracks just on the front and the back. Not like your GPU or motherboards at home that have 16 layers of copper in the PCB. If you look at your badge, all the surface mount components are just on one side. This is so that as it goes through a machine, it only has to go through once. And that saves on manufacturing costs. The screen itself is the only exception, but that has to be hand-soldered by the manufacturer anyway. We use KiCad to design the badges, and we're running a workshop in the Hardware Hacking Village on how to use KiCad to design your own PCBs. And if we stick to the standard copper track widths and the standard hole sizes that bring the copper to the other side, that also saves on manufacturing costs. These badges are produced on what's called panels, and we'll have multiple badges that then get cut out of it post-assembly. And if you have a standard small shape, that also helps. And the most critical thing about this year's conference is how to work around the silicon shortage. And for this, we came up with dual microcontroller footprints. What do I mean? If you look at the back of your badge, we have the ESP32 microcontroller, this one. And there's actually multiple variants of this exact same microcontroller. And the difference is how much internal flash, if any, is on there, and how much RAM is on that chip. And so we can already shift and pivot if these chips become unavailable or too expensive. But we didn't want to risk it just on one chip. So we implemented a CAM footprint, where you can put this PCB, which has an ESP32 in it as well. But it means that we've got this way that we can get twice as many chips if we have a shortage or a supply issue. This is all so that we can guarantee you a badge at this conference. Most important change this year, we introduced our first badge with USB-C. Why did we do this? Because it is easy. It takes 2 resistors and the connector to make it work with USB 2.0 speeds, which is the same you get on the iPhone 15 base model. And what does this give you? Well, you can power your bPod off your phone or laptop charger that you brought with you to this conference. Laptops have USB-C ports on it, so you can power it from there, as well as easily get to the USB to serial console interface that I was talking about earlier. And most importantly, we're going to use the battery pack that you already have, your phone. The bPod can be powered with the USB-C to USB-C cable directly from your phone, saving on e-waste and costs for this conference. Most importantly, as of a few weeks ago, Apple users can also make use of this feature. Which brings us to a controversial topic. We didn't just remove the headphone jack. We removed the battery and the case. And while there are many reasons for making these decisions, environmental and so likewise, we like to think of one major reason why we do this: courage. So we've got our design down pat. Let's have a look at the hardware. How do we go from this idea, these drawings, to a prototype, something you can hold in your hands? And so in KiCad, when you're starting a PCB, you design a schematic. And you can get access to this through the bPod update URL, which has this image on it. Complicated, but let's break it down. We have a small section for the USB, which provides data and power to the badge. So USB provides 5 volts. The microcontroller, the screen, the flash all require 3 volts. So we need a chip to make that conversion from 5 volts to 3 volts. We have a voltage in header on the board that you can use to attach an external battery pack that you can acquire from JCar, just a 3 AAA battery one, or you can repurpose from your 2016, 2017 badges. A boot and reset button, because it makes it easier for you to reflash and recover your badge as you're experimenting with it. It puts it into bootloader mode, and it's the same way for an ESP dev board as well. We want people to learn and interact with the hardware. If you go to the bPod update URL, you can see the link to download Arduino and the configuration for Arduino to be able to program your own software for the badge. And we provide these LEDs for those who are just getting started. Being able to toggle your LED on and off with your own code is the first step. We use only 4 GPIOs for that capacitive touch wheel that has the rotation and the clicks. And we do this using some very clever software that as you turn it on and use it for the first time, it will self-calibrate for your finger, which is why there's a slight delay. And this means that it works perfectly regardless of how fat your fingers are and how you hold the device. We've chosen a safer route. We've reused the screens that we used in 2016 and 2017 because we knew how they work and we knew that we could sort it out. But we added in a backlight circuit, and this is to protect the microcontroller to supplying current directly to the backlight, which can burn the chip. So we have a little circuit here where a little bit of current coming out of the microcontroller through the transistor controls a large amount of current going through the backlight. And then we have all the expansion headers. The shitty add-on header, SAO, for those badge add-ons that you might be seeing floating around the conference. The utility header, that's for all the tools, and if you want to do expansion. Might also be interesting for those who are doing the CTF challenge. We have the program header for the ESP32, but I should note that the whole badge can be reprogrammed through the USB port, and so you don't actually need to use this. And JTAG provides debugging capabilities. But I must point out that JTAG is not required to compete in the CTF, but you can use it. We have external flash and external RAM, and this is because we chose the cheapest variant of the ESP32S2, which doesn't actually have flash on board. So we have a separate part here for external flash to keep the cost down. When you use these chips, they often require an external clock signal, and this is what ticks the microcontroller on to do operations. Now, while it's easy to find a 40 megahertz crystal on the supply websites, it is difficult to figure out what capacitive values to use to calibrate it. And so a big shout out to my friend Josh up in the Hardware Village who helped me come up with these formulas that we provide to you. So if you ever have to do this, you've got a starting point. And coming back to the point that we have dual microcontrollers for redundancy to protect us against supply issues and cost. And so after we've done that, we have our schematic. And in KiCad, we then move on to PCB design. The workshop that we're running in the Hardware Hacking Village will take you through these steps in KiCad to design your own PCBs. And it's not black magic. It's not reserved for the elite. It's just a matter of trial and error and making your own PCBs, making mistakes, and learning. And it's perfectly fine, and I still do it. And we believe in the right to repair as well. On the afternoon of Saturday, after the CTS are finished, we will be making all the KiCad files available, the schematic, the PCB files, the ordering files. We will be making the source code fully available so that you can order, build, change, reprogram, repurpose your hardware the way that you see fit, as right to repair intends it to be. And then we get to software. And for me, this is the most important part, because without great software, these devices are going to end up in the drawers and cupboards of hackers everywhere. And we want to help people use and repurpose what they own for their own intentions. So how do we get from hardware to hacker engagement? Your badge comes with a Wi-Fi chip, Wi-Fi built into the ESP32. But we actually don't utilize it for this conference, but you are welcome to reprogram your badge to do so. And the reason is that putting Wi-Fi in the hands of 3,000 hackers is not the greatest idea on the planet. So instead, we opt to use things like QR codes to help people use the internet connection they already have on their phones. And on software, looking at the utilities that we give you, each of your badges is a full USB to serial device. And this is important because you can use your bPod badge to interact with your old router, your old fridge, your old camera. All these IoT devices will have some kind of serial header in it, and you can crack open the back and find it. You can then use your bPod to interact with that serial port and potentially get a root console on the hardware that you already paid for. We provide tools for working with I2C, and I2C is a multi-slave bus protocol. And so I2C Detect helps you discover the addresses of those random chips, flash chips, screens that you have lying around from other conferences, so you can then use them in your own projects. And we provide sniffing tools for I2C and SPI. We have a very limited number of GPIO expanders in the Hardware Village that you can actually use the badge to interact with. And so you can actually work through the process of wiring up I2C and SPI and learning more about it. All the information that you need to do this is actually in the tools section of your bPod. And if you don't get around to it, you can go online and buy these parts. They're like less than $5 each. And then you can experiment and start doing it. And I2C and SPI is the backbone of PCB communications. It's what helps a microcontroller or processor talk to flash, angle sensors, gyros, screens. SD cards support SPI communication. And then for the CTF, we have the usual candidates. And so already we've seen a lot of people compromise the security of our products, and that makes us very happy. I should note that in order to be the successful winner at the end of the day, you will need to show the badge and the serial number as you get called up to the stage. But then also we have embedded and worked closely with the cybers to give you a revolutionary CTF experience. And I will tell you more about this, except I don't want to give too much away. Most importantly, we actively choose not to do code signing or bootloader locking on your badges. Because while this would make for an exceptionally great CTF challenge, that would only be fun to do for the first 2 days of the conference. And then it's harder for everyone to repurpose their devices. And if you want to lock your bPod down and implement code signing, ESP32's websites have got heaps of information and documentation about how to implement code signing. And so because of this, your device is now hackable. We also provide the ability to update your bPod for the first time. And so if you go into the settings menu and you look at the QR code, it has a Python script, a single file that can be used on Windows and Linux, maybe Mac, that can be used to reflash and recover your badge. So you can feel free to experiment with Arduino and put your own firmware on it. It'll also give you the latest schedule. That URL also has the schematics, where to download KiCad, where to download Arduino, and how to program the badge. So all the information for you to get started on your hardware hacking adventure is right there. And then, how do we get to production, where it's in the hands of all of you fine people here? From a few to 3,000. We go through prototypes. And the first prototype that you see there in blue is literally us just dumping all the parts onto a PCB and finding out what doesn't work and how to make use of the new things that we want to put on there. And hence why there are lines running across, because there are lots of mistakes made at this stage, as you will make when you first start ordering your PCBs. Our second prototype, the one in black here, this is where it's good enough to start developing the source code, the software, the hacker engagement that we want. But we still have made mistakes. You can see the header on the side is sort of buried behind the screen. And the chips that we chose for this became too expensive and unavailable. And so we had to pivot. And then finally, we have this final prototype in purple. And at this stage, we'll order about 40 or 50 of these devices to check two things. One, we as hardware designers, did we make mistakes? And two, PCBWay, the company that we go through, have they been able to reproduce our design that is functional on multiple parts? Because the last thing we want to do is hit the button and pay the money for 3,000 badges that don't work on arrival. And so we get to this ordering phase. And my good friend Josh up in the Hardware Hacking Village put together this flashing jig that we were going to send to PCBWay so that they could manually flash the badges. But we didn't need to do that, and I'll get to that in just a second. To order from any PCB manufacturing website, you need to provide them with Gerber and drill files. This tells them where the copper tracks are going to be and how the PCB is going to cut out. And that is sufficient to get a board made for you without components on it. And KiCad can export these. And there's tutorials and instructions on PCB's website on how to do this. If you want assembly, like we do, because we don't want to hand solder parts the size of 1 millimeter across, you supply them with a bill of materials, which tells them what parts you want them to get for you. So you don't have to ship it to PCBWay, they can source the parts for you. And a pick and place, which is just a coordinate file, so their machines know where to go on the PCB and drop and solder the parts onto. And for this conference, if you don't want to burn out your volunteers, having them flash 3,000 pieces of hardware, which, by the way, I've done in the past, which took 30 hours of my life from me, you supply them with a firmware image. We sent our manufacturer, PCBWay, a 2 megabyte image of exactly how the flash would be laid out. And then they sent that to their flash chip supplier, who pre-flashed the bPod firmware onto chips before they even arrived to be soldered on. And at this stage, we should be good. We've got the parts, we've put our order in for 3,000, and they're just shipping to us. We're done, right? No, we are so not done. There are delays in shipping. And not just delays in shipping, the manufacturer can have lead times on parts where if some companies decide to release a smart light bulb and buy up all the chips that they need for that, all of a sudden, you can be hit with a 6-month lead time because the chip is unavailable. Customs, they can confiscate the 3,000 badges that arrive at the border and then ask us to pay money. And if you don't believe me on this, in 2019, when we did the Nokia badge, Echo, who developed the hardware, did such a good job of that PCB that Customs believed that it was a legitimate mobile phone motherboard. And they charged us accordingly. And finally, if we overcome all these hurdles, there is just one more. We've had boards that arrive at us that are missing solder, where the manufacturer hasn't put the screen on correctly or aligned it properly, and we've had to go through as volunteers and fix up each and every one of them. And then we pack them, and they arrive in your hands. And I'm so grateful to see that everyone has got one and that they are working, because this was the inception that we have for this conference every single year. And if I could just say one more thing. If you want to know more, try and hit me up during the conference. You can also contact me on these contact points, I guess. And yes, on that GitLab, we will make the badge firmware and all the files available at the end of the conference. Thank you very much for your time, and please enjoy the conference.
Do we have any questions for Pete? Wave your hands vigorously in the air if you want to ask a question. We've got a question over on this left side at the back of the front, just over there. Wave your hands and go over there. Thank you.
Hello, hello. How much was the cost of the prototype board you put together? Are they more expensive than the final product?
The prototypes that we make are definitely more expensive because they're in low volume. And so because we don't have the economy of numbers at that stage, and this is the same, so if you're doing your own PCBs and assembly, you'll probably get them in quantities of 5, and for that they'll charge more for the parts and the assembly. But then once you get to scale at 3,000, then you get access to more affordable options.
Are there any other questions at the front or at the back?
Hey, you're breathtaking. Thank you.
Look, I think that'll be it. Let's thank Pete one more time for an amazing badge.
Thank you.